Hello and welcome back. Seems like a lot of people have trouble with recursion, and I remember learning about recursion way back in the day, and it is tricky. I didn't understand, especially how the returns worked, how it stacked things up, and why it did what it did. So hopefully I'm going to go over it today with you, and hopefully I can show you kind of what I figured out just kind of on my own and make it a little bit more clear. So I made a recursive formula. I'm just going to call it Mystery 3. And I have a couple of different recursive formulas here. Here's one's factor this. That it's going to show you afterwards. But for right now, I'm going to show you this mystery one here. It does involve a return statement, so I have an int as my return statement. And I've got a lot of this echo printing. I don't know, I call it echo printing. I don't know what you actually call it, but I've got these print statements, and I found that that really helps me trace out what's going on. But I'll tell you right now that it works exactly like you would think a program would work, with one small little piece of information that I think a lot of us lack when we start this. And let me go over that. So first of all, I'm going to do a mystery. I'm going to throw it a integer of 3. So what happens is it starts off with mystery integer and it stores a 3. So right off the bat, there's a mystery 3 that gets stored, and I print this out right here. That's stored in the stack, okay? And then it says if n is greater than 0, which it is, it goes down here and it runs again mystery 2. And then so what happens is it immediately jumps out and starts this program over again and starts with a mystery 2. And then we'll print out mystery, and then you can kind of follow this along here. It says mystery and then n, which is 2, stored in stack, and it's going to print that out. And then it's going to do that for 1, and then it's going to do that for 0. It's going to have a mystery 0, and it's going to print out mystery 0 stored in stack. But then it's going to say if n is greater than 0, which it's not, and then since that's false, it jumps down here and prints this out, the code right after the if statement, and it's going to say n equals, and then it's going to have a little 0 down here, and it's going to return the value of 0. And then it goes back through the whole process again. But what's interesting is what happens to this statement right here. Like, does this ever get printed out, or is this just something that never gets printed out? So let's try this. I'm going to compile it, which I think I've already done. I'm going to run it. Remember, it starts off with mystery 3. Okay, so there we go. So this is how it looks here. So it looks just like kind of you think it's going to do. Mystery 3 stored in stack, 2, 1, 0 stored in stack. And then it goes down here. It says this is the code after the if statement. That's what we kind of guessed was going to happen. It says this is the code after the if statement because n is 0 at this point, right? It says mystery 0, and then this is what comes up. It says n is 0, so it jumps from here, does the test. It's like, oh, I'm 0, so I don't do any of the if statement, and it comes down here. This is the code after the if statement, and then it returns the value of 0. And then what happens is it goes through the other n's that are stored in here in reverse order, of course. But it says this is okay, so it's 0, and then it says this is the code directory directly after the mystery call. It says n equals 1, and then it returns a 1, and then this is the code directly after the mystery call. So it actually does print this out, but only after 0 has been taken care of. So let's see if we can trace this out and kind of give you an idea of what's going on here. So I have the program here printed out. This is the program, and I have it set up so hopefully it's a little bit more understandable. And what I do is I have my two recursive formulas here. In this example, I have this commented out, but what I just showed you just a second ago, this was not commented out. And I think I actually have this one commented out here. So I'm going to throw a 3 down to the mystery int here. Let me just make sure I get this. Is kind of tricky, so I may have to pause the video while I figure this out. But so I'm going to throw it a 3 down here. So I'm going to put in a 3, and then you can kind of follow along. It says system out println mystery It's going to be a 3 stored in the stack. If that's then it's going to do a mystery, and it's going to throw in a 2, and it's going to skip the rest of this. It's not going to do any of this stuff, and it's going to do mystery 2. Well, mystery 2, what it does is it actually runs this program again, except it's a whole new instance of this program. This one isn't buried and forgotten. This one is going to be run at a later date, but for right now we just called this mystery 2, and it suspends its activity because it's waiting for a return from another instance of mystery. So we have to, the compiler starts up mystery again with 2, and then it prints out mystery 2 stored in the stack. 2 is greater, so it's going to start up a mystery number 1 right now. Well, it doesn't finish it. It's going to actually call that instance, and it's waiting for a return, remember, of 1. So it starts up this one. Remember, we've already got a couple of versions of this program already up and running. They're just waiting for something to return back to it. So it's going to start up a 1 because 1 is stored in the stack, and now it's going to send in a 0. So it got past this one because here n is 1, right? N is greater than 0. So mystery 0. Okay, so it suspends its activity and sends in a 0. Now it says 0 is stored in the stack. 0 greater than 0. Well, this is false here. So it's going to come right out here, and it's going to print out this is the code after the if statement, and n is equal to 0. And then it returns the value of 0. Now once it returns it, where does it return it to? Does it return it up here? I mean, this is where we originally called it, but this isn't the one. This mystery here is not the one that called this version of mystery. This version of mystery was called by this one right here, right? So because this one was waiting, waiting for a return statement, and then finally it returns a 0, this one starts off. So remember, this one was waiting for a return statement. Now it's ready to go, and it returns a 0, so it does not run this part because n is greater than 0. So it says this is the code after the if statement, and n is equal to 0, and it returns a oh shoot, let me see, hold on a second. And what it does is it returns a 1 in this case, because in this instance of the program, n is 1. So it returns a 1 in this case. See, n is 1. So it returns a 1 over here. And because n was greater than 0, in this case, it's going to run this thing right here. It's going to kind of take off where it left. N was 1 right here, so it's going to return a 2. I think I'm getting this right here. And then right here it's going to come back here, and it's going to actually return a 3. Because I didn't really change anything with n, but ultimately what gets returned is the value of 3. So if you go up here, it's going to return the 3. So if I run it now, let's see here. If I run it, actually I already did. See, what gets returned is the value of 3. Right up here, let me show you. So I said system.out.println mystery, and this is what is returned. Let me actually highlight this. I kind of like how this works here. Copy, paste. Oop. Okay, now I compile it. See if I got all that right. So let me run it. Okay, this is what is returned, is a 3. Remember, try to if you're still stuck on it, sometimes it really helps to make one of these little flip charts. You're not going to have to do this for the rest of your life, obviously, but it really helps to, I think it really illuminates how this whole thing works. This program isn't being run just one time, and n really isn't even changing. N is going to be 3 on this piece of paper, and it's going to be 2 on this piece of paper, and 1 and 0 and so far on the preceding piece of paper. But you can kind of see how the computer flips through the versions of the code, and then once it gets something where it actually returns a value up to this point it wasn't really returning anything. And once it returns a value, then all these other things get triggered, because this one was waiting for a return value. So then now it fires off its return value, and this one was waiting for a return value, so it fires off its return value, and then this one was waiting for a return value, so it fires off its return value, but its return value was being waited for by this call up here. So you can kind of see how that backed up that way. All right, next I'm going to show you how this other one works. Very similar, but it does a little different thing that I want to show you. So stay tuned.